Hello, everybody. How are you all? Hope you are doing great. I'm Yogeshkumar Rathod, very few amongst the highest degrees achiever in the world. Welcomes you all to my lecture on engineering thermodynamics. Engineering thermodynamics is the study of thermodynamics. It deals with the behavior of matter. Engineering thermodynamics is based on common experiences which have been formulated into thermodynamic laws which governs the principle of engineering thermodynamics. Engineering thermodynamics principles are applied in the field of steam and nuclear power plant, internal combustion engines, gas dynamics, refrigeration, air conditioning, compressor, direct energy conversion devices, chemical process plant, etc. There are two points of view by which behavior of matter can be studied. Classical thermodynamics, in which certain quantity of matter is considered. Another word is statistical thermodynamics, in which myriads of molecules are considered. There are altogether four laws by which engineering thermodynamics known. Uh, First law is Zeroth law of thermodynamics. Zeroth law of thermodynamics states that when a body A is in equilibrium with body B and also separately with body C, then B and C are in thermal equilibrium with each other. This is Zeroth law of motion, thermodynamics. First law of thermodynamics is the principle of conservation of energy. Energy is neither created nor destroyed, but only gets transformed from one form of energy to another form of energy. Q minus W is equal to delta E. Second law is given by Calvin Planck statement, which tells motive power can be produced when there is a difference in temperature. Work can be produced. Clausius statements tells about heat cannot flow from lower body temperature to higher body temperature. Some work must be expended to achieve this. Now, Simon is the third and final law of engineering thermodynamics. It is independent law of nature. No matter how idealized a system uh, should be, it cannot reach to absolute zero of temperature. There are closed system, open system and isolated system. Closed system is one which is internal combustion engine. Is an example of closed system. Open system is a compressor. Isolated system is one which covers insulation around the body. System outside the system is known as surrounding, and system and surrounding together comprises of universe. There are various processes. Isochoric process volume is constant. Isobaric process pressure is constant. Isothermal process, temperature is constant. Polytropic process, PV to the power n is constant. Cycle is one which starts from one point to and ends to the point where it started. Is the cycle which comprises of various processes. There are vapor compression cycle, vapor absorption cycles in refrigeration and air conditioning. Hey, please like and share my video. Please subscribe my YouTube channel Tech Yogeshkumar and Engineering Yogeshkumar. You should be aware of perpetual motion machine of first kind, perpetual motion machine of second kind, perpetual motion machine of third kind. There is enthalpy, entropy, which one should be aware of. Plotting of PV diagrams, TS diagram, and HS diagram is the important aspects of engineering thermodynamics. I'll give you more information later. Thank you.